Grounding and bonding. Grounding and bonding, guys, Article 250. Let me just quick repeat what I've said a second ago here. We have a service. If you guys can look at right in here, you have your service. This is my service entrance coming to the building. From the service, I took a feeder and I fed my mechanical panel or lighting panel, any other panel, sub panel. And also from the same service, I went through a transformer, Spencer. I went and I fed a receptacle panel. You guys have done that with me. To a transformer, we feed the receptacle panel from the same, which is this one. This is my receptacle panel to a transformer. This is my lighting panel or mechanical panel. And also from the same service, I fed a different building, a second building, to a feeder. So what are you guys supposed to do? We're supposed to size everything green. Everything green is bonding and grounding. Everything colored, obviously, is not. So I'm going to just draw a couple of things, guys, to give you an idea. This would be, most likely, this will be a 480/277 volt system. This transformer will be 480 on the primary. On the secondary will be 208/120 volt. This panel will be 480/277. This panel will be 480/277. They don't have to, but this is one option. This panel here will be 208/120 volt. Okay? 120 volt. Everybody can see what the system is, guys? And what am I required to do? I'm required to find the bonding and grounding for everything. I'm going to start reading with the numbers, what the numbers means, guys. If you look at number one is grounding electrode conductor. Number one, if you guys look at the back of the page that I gave you, number one is, which is this one here, is grounding electrode conductor. Grounding electrode conductor, when we size it based on table 250.66, based on the service entrance conductors coming to the building. If you parallel, you have to multiply the service conductors by how many runs you have. Done. So Spencer, if I give you the amp right now, and I ask you to size this the service for this one, anything number one, can you guys see where number one is? Number one is right here, this conductor. Everybody can see where the conductor going from the ground bar in the switch gear into the ground bar on the wall. When we were yesterday at Cummins, guys, do you remember when Tim pointed to you that ground bar on the wall and he said the generators are all grounded, bonded to that ground bar right at the top? It was like just a little bit below the structural ceiling. I don't know if you remember that. So this is number one is my grounding conductor, my grounding electrode conductor. So wherever you see number one is actually my grounding electrode conductor. Number two.
Is it based on what size wire conductors?
It's based on, read this one here, based on 250.66. Based on 250.66. On the service entrance conductors. So, no, the name is big deal. A service entrance conductor is not a feeder.
Yeah, I know.
Is not a service entrance conductor.
So it's based on the service entrance conductor.
Yes.
But it isn't if it is that other deal.
Hold your horses. Service entrance conductor, that will be your number one. Number two, guys, if you look at number two, there's special condition for number two. Number two right here is basically the grounding electrode conductor that's going to a pipe or a ground rod. The only reason why I split this one is because you don't have to go more than number six. If you guys read number two, it says the same thing, 250.66, based on the service entrance conductors, and number six is maximum. You don't need to go for higher than number six. Number three, Spencer, if you look at number three is actually the system bonding jumper. Can you guys see it's going from the neutral to the ground? You have to bond the neutral to the ground at the service. You have to bond the neutral to the ground at the service. How do you size the main bonding jumper, guys? It's 250.66, right? Based on the service entrance conductors or the feeders of the service entrance conductors. And if larger than 1100 kcm, you take 12.5% of the feeders. We're going to take an example in a second. Go to number three. Number three, guys, so that's number three. Number four here, can you guys see number four? Number four, this is a conduit. By the way, this is right here is a conduit. Number four is basically bonding the conduit to the ground. You bond the conduit to the ground under certain circumstances inside the switch gear, because if you come from the switch gear, guys, it's not mechanically tied to the switch gear. It's open switch gear. So you bond it. How do you bond it's called equipment bonding jumper line side? Why do you guys think it's line side? Look at that line side, because the overcome protection device, the main is on, it's on the line side of the main. The main is right here, and it's on the line side of the main. How do you size this one? Exactly like the equipment bonding jumper, the system bonding jumper or main bonding jumper. Can you guys see that? 12.5% if it's more than 1100 kcm. Any question about number 4? Number 4 might be confusing. Number 4 in a few locations.
Space is the same as 3.
Number 4 is also right here.
But not line. 4 gets to this line.
So
Yeah.
you're saying 4 is spaced it's size exactly like as
Yes.
3?
Yes. Number 4. Equipment bonding jumper on the line side. Number 5, guys, equipment bonding jumper load side. Where's number 5? Number 5, can you guys see that? Number 5, it's in a different location, here and here and here. It's a multiple location that you could encounter this. And this is equipment bonding jumper. We size it based on the overcome protection device. 250.122 based on the overcome protection device. Number 6, electrode number 6, guys, if needed. This is the equipment grounding conductor. We all know how to size it based on the overcome protection device. Number 7, system bonding jumper. Can you guys see number 7? System bonding jumper. This is for the separately derived system. System bonding jumper for the separately derived system. That what takes the neutral of the transformer bonded to the ground. That's number 7. And the last one, guys, grounding electrode conductor number 8. Where did they put number 8? Grounding electrode conductor. Where's number 8? Let me see what the sheet. Number 8, yeah, grounding electrode conductor right here. Number 8, grounding electrode conductor for the separately derived system. That's for the separately derived system. Separately derived system. Any question, guys, about this? Any question? And the same numbers are identical. If you guys look at wherever you see a 6, you size it basically the same. Wherever you see a 1, you size it the same way. So if you look, guys, I have a 6 here and a 6 here. It's the same equipment grounding conductor for different panels. Any question how the system is put together? I want to remind you guys, we're looking at a few things. Number 1, grounding electrode conductor. Number 2, equipment grounding conductor. Number 3, main bonding jumper. Number 4, system bonding jumper. Number 5, equipment bonding jumper on the load side. Number 6, equipment bonding jumper on the line side. And exactly they're identified as you're looking at it. The line side, when we talk about Brooks, when we talk about the line side, we're talking about the line side of the overcome protection device for the main overcome protection device. Any question, guys, about this before I throw an example for you? Any question? So if you are encountering, this will cover 99, the only thing that's not covered here, guys, 2 things, medium voltage and also DC system. Other than medium voltage and DC, this will cover every single system, 288-120, 48277, 240-120, any system that you want. 95% of the system that we'll be working on is right here, grounding and bonding. When do we bond the conduit, guys? You bond the conduit of most of the time, you bond the conduit if you're encountering the eccentric and what's the other one? Eccentric and concentric knockouts. But that's up to the contractors. But for the most part, guys, if you have a conduit, most part, 2 inches or larger, you usually have a bonding, we bond that conduit. Why do we bond? Because we want all the electrical, the steel system to be on the same potential, number 1. And of course, we want it to be grounded. So if you have a ground fault in any one of them, the circuit breaker will wake up. Any question how this system is put together, guys?
25092 tells you when to use it for concentric and eccentric.
Absolutely. Now let me give you a disclaimer. You don't need all of this all the time. Some of them, like for example, do I need an equipment grounding conductor if my conduit is EMT or metallic? No. But if you need it, this is how you size it. If you need it, this is based on if you need it, this is how we size it. Let's take an example right away. Let's take a 4,000 amp switch gear. So I'm going to go, guys, and take a snapshot about this here. Okay, got a snapshot. Let's take an example. Now I'm going to erase a few of this stuff that I've done, guys, and take my example. Wow. Right here. Okay. And let's go size. I'm gonna go with red. Okay, so this is a, oh, okay, there you go. This one, a 480, now what? 480, come on, buddy.
Okay.
What do you want? What do I want?
There's a message from earlier to-
Oh, why don't you guys tell me that there's a message in my screen? I thought we were
You're
friends.
trying to.
Still not writing for me.
You're having a good day, are you?
Almost. Doesn't want to write for me.
Oh dear.
You need a transformer to make it separately derived system.
Yes, thank you. You need a transformer to make it a separate derived system.
Okay, let me see if we have a lock here now. No, we don't have no lock. Why did you stop talking to me, buddy, old gal?
Service.
No direct.
Yeah.
Well, we can do the other way. There's always two ways of doing things, huh? Let's do it this way. Okay, let me
write a few things. Here's the voltages that we wrote about this one, guys. I'm gonna write the amps. So this switch gear, the first switch gear here is 4,000 amp switch gear. 4,000 amp. Can you guys write that one? 4,000 amp switch gear. This panel here is 225 amp panel, and this panel here is 2,000 amp. 2,000 amp panel. This panel here, let's make this panel 1,000 amp panel. Okay, so I need to size everything for this system. I have a 4,000 amp switch gear feeding a 2,000 amp panel and a 1,000 amp other panel, and also feeding through a transformer, 208, 120, 225 amp panel. And I need to size all these eight things. I want to remind you guys, when we go to a separate building, look how we have to create the same thing. You have to create a grounding bar here, and you have to tie to every grounding electrode system in the second building. Exactly like in the service. See how this one looks like exactly like this in the second building. Any question? This is the example that we're going to have. Any question, guys, about this? So I have a 4,000 amp switch gear feeding a 2,000 amp switchboard through a transformer. We're feeding 225 amp panel, and also we're feeding a 1,000 amp switchboard or panel board in a separate building. Any question, guys, about this? Any question? So if you want the one-line diagram for what I've just did, this is how it's going to look like. Basically, this is my panels. This is from here to a transformer out of here. So that's basically what we're doing. This is my 4,000 amp switch gear. This is my 2,000 amp. This is my 1,000 amp. This is my transformer. And this is my 225 amp. And I want to size, I don't care about you guys know how to size the conductors. I care only about right now about the grounding for this system. That's how this system is going. Just FYI, all these are in one these are in building. This is building A. This one, this guy, no, the other way around. Well, we can make it, which one is the 1,000? Let's make this one the 2,000 just to, because I already draw it. This will be a 2,000 amp, and this will be my 1,000 amp. So this will be building B. That's the only difference. One in building A, one in building B. They're all tied together like you're looking at it, guys. We're going to size them. How do you size them? We're going to size based on these rules that I gave you right in here. Based on these rules that you guys are looking at. Any question? I hope, guys, this graphic will tell you what you need for every panel and how do you size it. What you see, all the green is grounding and bonding. You need it. You need everything. Well, most of the time you need it. I want to bring to your attention, guys, that there's white here. There's that neutral. Look at that neutral. My white conductor for the neutral. 28, 120 system, 480 everything else. Okay, let's go size. When we go size them, my friends, we're going to go to the first thing. We're going to go size the 4000 number one. I want to go size number one. So number one, right? Number one. What was number one, guys? Grounding electrode conductor. I want you to look where number one is located, guys. Grounding electrode conductor. When we size number one, guys, we size it based on the service conductors coming to the building. So I have a 4000 amp. I'm going to parallel 12 runs. I have to have the conductor size, guys, for this one. 12 runs. I end up with 333 amps, 333 amps, right? And then to run it, I need 12. This is service entrance conductors. You need to find the service entrance conductors, guys. I decided to parallel 12 runs, as you guys have done. So I have 12 sets of, if you take this one to 310.16 table, 310.16, this will get you, if I did that one run, 400. 4 conductors, 400 kcm. 4 conductors, 400 kcm. That's step number one. Size the service entrance conductors. Size the service entrance conductors. That will get you a 400 kcm right here. 400 kcm, 4 of them, why 4? 4 conductors, 400 kcm. Okay, the second thing, guys, if you look at how the sheet that I gave you, how do you size the ground electrode conductor? Are we paralleling? Are we guys paralleling? Yes, we're paralleling to it. So you take the 12 sets. Since we're paralleling, you're going to take the 12 sets, multiply them by 400 K. And if you take the 12 set, multiply them by 400 K, you're going to end up with a 4800. If I did that right, kcm, right? Kcm. And then you're going to ask yourself, are the 4800 kcm, is it more than 1100 kcm? The answer is yes, right? Then you have to take 0.125 times 4800 kcm. And if you guys divide, if you do the math on that one, you're going to end up with, where are we here? Okay, so we take the 12.5%. I'm sorry, you don't have to do that one for the bonding jump. You don't have to do that one. This is for the bonding jump.
Electrode.
Yeah, the grounding electrode conductor, no need for this. Grounding electrode conductor. So you take the 4800 kcm, take it to table 250.66, and that'll give you the largest is 3 aught. Done. The equipment grounding conductor is 3 aught. No question asked. 3 aught. That's the largest that you can do. Can you do a 250? Yes, if you want to, but the largest is 3 aught. Any question, guys? Any question about the grounding electrode conductor? Everybody know where this conductor is located on the graphic that I gave you?
That's four conductors.
One conductor, Mr. Abab.
One conductor, yeah.
One conductor, this is right in here. We're sizing that conductor right in here.
Okay.
One conductor. Good point. Maybe I should put one conductor here. One conductor. Okay? One conductor, 3 aught. One conductor, 3 aught. Any question, guys, about the grounding electrode conductor? That's not the first time we touched it. I know you probably guys remember some of it.
What type of insulation is that?
Could be bare, insulated, or all the grounding and bonding. By the way, good question is what type of insulation? They could be bare, covered, or insulated. You can put the HHN, you can put anything you want. Any question, guys? Any question about that number one?
What's usually cheaper, the stranded or the bare?
Number one. Any question about number one?
Which is usually cheaper, stranded or solid?
For
Solid's always cheaper, but
you can't
Solid
get
is-
4-aught solid, 3-aught. You can't get 3-aught solid. After number what is it? They stop at number 8. 8 solid, and then after that you go stranded. So you can have no option. I guess they can make. I've never. You can't make 3-aught. Never seen it.
solid's always cheaper, but it'll take you 10 times as long to pull it.
Number 2. Number
It's
2,
like
guys.
Gilbert scam. Like get the
If you
scam.
guys look at number 2, based on the sheet that I gave you guys, if you look at number 2 is the same thing, grounding electrode conductor. Grounding electrode conductor, I call it special. Why special? Because it's going to a rod or water pipe. It's going to a rod or a water pipe. So if you guys, based on this, the same calculation, same as one, no need for more than number 6 though. You do the same calculation as in 1, but you really don't need to go higher than number 6. If you don't believe me, guys, you go to the code, right under 250.66. It will tell you if you're tying it to a rod or a pipe, you don't need to go higher than number 6. Special condition, rod or water pipe. Special condition.
You know, code it.
250.
66A.
250.66A.
250. Thank you. 250 to 66A. Any question guys about number 2? Because before we move to number 3, main bonding jumper, piece of cake. Main bonding jumper. The difference, guys, between what we've done before and with this sheet just will show you where all these have to be located most of the time. Any question about number grounding electrode conductor? 1 and 2 are the same type, but there's 2 is special because it's going to a rod. And if you guys go to a plate, I can't remember, it's number 4. There's a couple of special for. I don't have the plate here.
How they save, and you say this one because it's one number 1, number 6, and the
Yeah.
other one is 3-aught.
Yeah,
How they could be saved?
Mr. Rebel, the same type. This one is going from the switch gear to the bar, to the grounding bar. This one going from the grounding bar into a pipe or a rod. That's the difference between them. Where are they used? But they're the same type. It's a grounding electrode conductor. Grounding electrode conductor.
My question number 1, you said 3-aught, and this one is one number 6.
Mhm.
So how could they be saved?
Code on 250.66A.
250.66A, because it's going to a rod or a pipe.
Mr. Rebel, they're the same type. They're called grounding electrode conductor, but they're used differently.
I see.
That one here is going from the switch gear to a ground bar on the wall. That's why we size it directly based on 250.66. The second one going from the ground bar to a pipe, we use the same table, but there's some exception in the code where it tells you, hey, if you're tying to a rod or a pipe, you don't have to go higher than number 6.
Okay, all right.
You just don't have to.
Yeah,
It's
yeah.
an exception.
Oh, yeah, okay.
You don't have to go
Yeah.
higher than number 6.
Yeah, you follow this, yeah, you don't have to go, okay.
Everybody's seeing that? Just special condition for these 2, you don't have to go higher than number 6. Number 6 here. 3. Number 3, guys. Number 3, if you guys look at number 3, is main bonding jumper. Main bonding jumper. Main bonding jumper, it bonds the grounding bar in the switch gear to the neutral bar or the grounded bar in the same switch gear. So we size it the same as number 1, guys. Same as number 1 with some exception. So do you guys remember? I'm going to say same as 1, but here's the but, big but. If, and you guys see that if I'm not going to write it here, so when you go say the but, what we end up with 4 kcm. Is this more than 1100 kcm? The answer is yes. Then this is where you use the 12.5%. 0.125 times 4800K. Don't forget the K. And if you guys size it based on that, so same as one, except if it's higher than 1100 kcm, you have to do some different deal, and that will get me 600 kcm. Is that even 600 kcm?
Yes, it is. I think so, but-
If you are, if it's not, you take the 600 kcm. Do you guys remember? If you came up with something different, take it to chapter number 9, table number 8, and that will get you 600 kcm. Everybody knows how to go to chapter 9, guys, table 8. Say, for example, Spencer, suppose I came up with 533.3. 533.3 kcm. What the heck is 533 kcm? Which standard size? You take it to chapter 9, table 8, and that's where you find the standard sizes, conductor sizes that we use in this type of industry. Any question, guys, about this? Main bonding jumper, same as number 1, except but. Remember the but. If it's more than 1100 kcm, cover. We're talking about cover. Yes, then you have to go do this second step.
What do you mean it's same as? That just doesn't make sense. It's same as one.
Same as 1
What's the
in terms of calculation. Remember how we did
Calculation.
calculation-wise? We did it.
4,000 divided by 12.
Yes, yeah.
33 amps.
Yes. Up to this point, I'm finding 480.00 kcm is the same up to here. Then you apply this step. Right? Everybody's getting that one, guys? Jim, my friend Camille. You do the same as 1 as you find the 4800 kcm. Then if it's more than 1100 kcm and it's telling you the sheet that I gave you guys, you have to multiply by 12.5%. 12.5%. Where do you find this in NEC code book? I thought I said the code for it. Main bonding jumper 250.28D. 250.28D. Any question, guys, about the main bonding jumper? Questions about main bonding jumper? Questions about main bonding jumper? What's number 4? Equipment bonding jumper on the supply side. Table 250. Can you guys see this is the same as number 3, right? So number 4, if you read it, number 4, equipment bonding jumper supply side. Equipment bonding same as number 3. So what's the answer would be then? 600 kcm. How many? 1. 8. Oh, that's it. And did I say how many of these here, guys? Always 1 here. 1 here. Same as. The only difference, Spencer, is one of them is tying the neutral to the ground. The other one is tying the ground to the conduit. The ground to the conduit.
Or if it's metal conduit,
Thank you. If it's
then you don't need it?
if it's a metal conduit, if it's a metal conduit, no. If it's a metal conduit coming from an open switch gear, the bottom is open. So you're coming from the ground and it's not attached to that's how most of these are. Switch gear sitting on a conduit. The conduit's not attached to the switch gear. That's when you bond. Now, if the conduit has a hole and the hole is with lock nuts and threaded and all this good stuff, then you don't need this. But a lot of people do it anyway, guys, because of good grounding. But most of the time, guys, these coming from the bottom of the switch gear with rigid metal conduits, and you have to bond it to the grounding bar inside the switch gear. So yes, there are exceptions where you don't need it. As a rule of thumb, here's how I do. As a rule of thumb, guys, unless you're using threaded anything 2 inches or more, size the equipment bonding jumper. Tying the conduit to the ground bar. The conduit to the ground bar. Any question about 4?
What do you do? Just tie a strap on the.
They have a grounding, what do you call them here? Help me. Grounding logs.
what do you-
Lock nut.
lock
grounding
nut.
lock.
So the conduit will be here, and you have right around the conduit, you put this piece that looks like this with a screwdriver in here, and you put your grounding conductor. This is the conduit, and you tie it right in here, and you go to the ground bar. So there's a grounding bushing that you ground directly to it. Grounding bushing. Good point though. Grounding bushing. If you work for electrical contractors, that's a big deal, guys. I mean, you're going to be sizing these. Any question, guys, about this? Grounding bushing around the... Any question? Let's go do number 5. What does number 5 say? Number 5 is equipment bonding jumper, load side. Equipment bonding jumper, load side. Equipment bonding jumper, number 5 is equipment bonding jumper, load side. Okay, now because it's load side, you have to size it based where it's located, guys. So this is number 5, and number 5. You have to size it. In this case, you have to size it based where it's located, right? So let's just do. What was the switch gear? Or was it the sub panel? Did we say 1,000? The sub panel was 2,000. So I'm going to say there are 2 of them. For the sub panel, which is, what was it, 2,000?
Sub panel, you said 200.
So it's 2,000 and 1,000.
Oh, I wrote down.
2,000, I thought. Did they wrote it 200?
2,000 for the sub.
Yeah.
You're right,
You
2,000.
did? There you go. 2,000. So we're sizing, guys. We're sizing this right here and this right in here to the conduit going to the 2,000 amp switch gear. This one, I'm not going to size it to the transformer. I can, if I want to size it, the one that's bringing to a transformer, I need the main that's coming to the transformer. I don't have the main that's coming to the transformer. Can you guys see where this number 5 is? This is tying the conduit, this conduit to the 2,000 amp switch gear conduit to the grounding bar from both sides. Okay, so I'm going to go size it, guys, directly based on. If you read through what we're saying, guys, for number 5, it says table 250.122 based on the overcomputation device. So what's the overcomputation device here? 2,000 amp. Take this one to table 250.66. Oops. 250.122. 250.1, 2, and 2. And if you guys, if I size these, you'll have 250.122. Your 250 kcm. How many? Well, you're going to have 1 for every conduit that goes to that switch gear. If you parallel, you're going to put 1 in every conduit. So I'm going to put the question mark here, or question mark here means 1 for every paralleled set. 1 for every parallel set. If you parallel 10 sets, you have 10 of them. 1 for every parallel set inside the set. Are you guys with me here? So if I parallel 3 sets, 1, 2, 3. Suppose I parallel 3 sets to carry this feeder. You need 1 here, 1 here, and 1 here. Everybody's following with that one, guys? Oh, no, Chad. I think I'm doing the equipment ground conductor here. Don't listen to me. I'm doing the equipment ground conductor. This one is basically 1, right? You can see what we're doing. That's what I said. This is going to be only 1. Everybody can see why? Because we're just tying the conduit where it's located right now. If you look at the diagram, based what we call it, guys, it's just tying the conduit to the ground rod. Can you guys see that? Where number 5 is located, it's just tying the conduit to the ground rod. So it's 1. It will be right for the number 7 is be right. Number 7 will be right. or number number six. Number six would be right. Okay. Any question guys about number 5? Let me write number 6 right underneath it because they're very related. This is grounding, no, equipment. Number 6 is equipment grounding conductor. For equipment grounding conductor, the same calculation, guys. You take the 2000 amp, take it to table 250.122, and you end up with 250 kcm. Now, how many? Here's the question: is how many? That's when you guys have, when you put, I'm going to say the x here, x equal number of paralleled runs. X equal number of parallel runs. Now that's when you have the parallel runs. Why? 1, 2, 3. Suppose that I parallel 3 runs for this feeder. 1, 2, 3. Then it will be x will be 3. Suppose I parallel 10, x will be 10. Any question, guys? Why I put x? How many of them do I need? 1 for every parallel set. If you only have 1, then 1 set, then you only talk about 1. Ben, my friend. Any question, guys, about this? See, can you guys see that 5 and 6 are identical? Except 5, you only need 1. I guess 1 on every side of the conduit. You really don't need. You need bond one side of the conduit. It's a good idea to bond both sides, but you can only bond one side of the conduit, especially if you're using an equipment grounding conductor. Any question about number 5 and 6 before we move into number 7 and 8? Everybody guys can read the stuff that I wrote at the back of the how to size them. So when we have a test, please bring this one directly to the test. That one, the sheet. No problem, right in front of it. Keep it. I need to update it a little bit to the 2011. There's no major update other than names. They changed the names a little. Any question, guys, about the equipment grounding conductor and the equipment bonding jumper load side? By the way, why do they call them load side? Because they're on the load side of the service. Everything is by the service. A service disconnect means is here. If I am down here, that's a load side. If I'm up here, that's a line side. Number 7. Number 7, I want to remind you guys by where number 7 is. Move, Chad. Oops, there you go. You guys see where number 7 is? Number 7 is actually the system bonding jumper. Right? Is that what we call it? System bonding jumper. For the separately derived system. Now, Spencer, I created a delta Y. I created my new neutral. That's called separately derived system. Every time you create your own neutral through a transformer, most of the time, or generator, or UPS, then that's called separately derived system. You bond the neutral to the ground. You bond the neutral to the ground. Can you guys see where number 7 is? Number 7 is right here, bonding the neutral to the ground. Number 7 is bonding the neutral right here to the ground. Okay? All right, so we size this one. If you guys read based on number 7, it says, based on the largest, blah, blah, blah. So you're going to size it. And exactly like the number 6, number 7. So number 7 is, number 7, with main bonding jumper, same, we call it, what do we call it? System bonding jumper. System bonding jumper. And I'm going to say here, same as number 3, calculation wise. Same as number 3 calculation, except the calculation is going to be similar, guys, but the feeder is going to be different. Okay, same calculation, same concept. So Spencer, I have 225 amp. I need to size the conductors for 225 amp. 310.16, table 310.16, size the conductors for this panel. So number 7, I need to size the conductor for this panel. Says system bonding jumper.
What's the so what's the what is it 4-aught? 4-aught? Okay. So I have conductors 4-aught. How many? I need 4. The first thing, guys, this is the first thing I size right here as feeder conductors for the separately derived system, right? I have a 225 amp panel. I just sized the feeder for it. The next thing, guys, the next thing you need to do is just take the 4-aught and take this one to table 250.66. I don't have the right here. What's Spencer? What's Holly? Number 2. How many? 1 conductor number 2. 1 conductor number 2. This one, the one that you guys are going to bond the neutral of the separately derived system to the grounding bar inside the panel or inside the transformer. Doesn't matter. You can bond them inside the transformer or you can bond them inside the panel. So same as number 3, DJ, it's not same as in like the calculation, the answer is the same. The calculation is the same way. The calculation is the same way, right? First you size the feeders and then you size based on the feeders. Did we say that in the number 7? Size based on the feeders. So number 7 says 250 to 66. If larger than 1100 kcm, take total of the feeder. Yeah, the same you're going to apply if larger than 1100 kcm.
And we know that the secondary amps will be more than the primary.
Yes,
So
yes,
good.
yes, yeah. And we always size it based on the secondary of the transformer, because that's what the separately derived system is. The primary is just 3 wires delta. If you guys look at, we size this based on the secondary. Look at this. Go back, Chad, here you go. Can you guys see the primary here is a delta? I don't have a neutral to title. We created the neutral on the secondary side. Can you guys see that? Here's where neutral created, and that's where I bonded the neutral. I created the neutral on the secondary side, so I size the neutral based on the secondary of this transformer, which is in reality, it's the cables that's feeding this panel. Wow, you're in a hurry, man. Any question, guys, about this? Any question about this? Okay, number 8, I want to bring to your attention that number 8 is grounding electrode conductor. Grounding electrode conductor, number 8, guys, is the grounding electrode conductor for the separately derived system. The same thing. The only reason why I called it number 8 Brooks, because it is a grounding electrode system for the separately derived. The same calculation. So go back. Oops. 7, 8. So number 8 is grounding electrode conductor for what? For separately derived system. For the separately derived system. So the way we size it, guys, you take the, I want to say same as number 7. I'm going to say the but if it's more than 1100 kcm, then multiply by 12.5%. So in this case, guys, is it more than 1100 kcm? No. So that's that conductor would be, what was the size that we came up with, Brooks? We came up with 4-aught, and the 4-aught 250.122. What was the number 1 or number 2? Number 2. 1 conductor number 2. Done. Everything that you need to know about bonding and grounding in one sheet. Any question, guys?
Any questions? Number 8. Any question how the sheets is put together, guys? What's what? So Spencer, when I said number 1, it's here, and also if you're doing it for the same building, separate building, it's also called number 1, the same way, same calculation. Number 2, can you guys see that there's number 2 at the bottom here, and number 2 at the top? It's the same calculation. But it's just for separate building. Homework. This could be homework. Really is, if you guys follow the sheets, it's straightforward, no gimmicks, nothing to it. Mr. Bab, when you're done, I'm hungry, man.
Yeah, it's done.
Oh, done? Okay. Any question, guys, before I go about the sheet and the back? This will help you a little bit. Let's go to the homework. Here's what you're going to be your homework. I'm going to write it here on this. So let's say, which one homework is that? Number 7? Great, thank you. Homework number 8. I'm going to write, I'm going to give you just different numbers, guys, if you can imagine. Let me use blue. So homework number 7. Homework number 7. For homework number 7, guys, I want you to size. Here's which is homework number 7, right in here. I want you guys to size. This is 2000 amp. This one, we size this one based on, let's size this is 400 amp. This one as 800 amp. And this one is 1600 amp. 1600 amp. Done. 2000 amp feeding 1600 amp and 800 amp and 400 amp to a transformer. And do the same calculation. Same calculation, 8 things. Everybody's with me, guys? 2000 amp feeding 1600 amp direct and an 800 amp direct. And through a transformer, we're feeding a 400 amp. Through a transformer, we're feeding a 400 amp. What are you required to do? You're required to size all the bonding and grounding conductors for this system. Bonding, grounding conductors for this system. Here's how the system is put together. Now, would it make a big difference, guys, if I added another 15 panels like this, sub-panel? Same way, same sizing, same way of calculation. Any question, my friends? Homework number 7. Any question? Yes, sir. Jim? Is it 8 or 7? Oh, why did I write 7? Number 8. Homework number 8. Any question, guys? Any question about this, how the system is put together? Now, here's my question for you guys. My question, if that switch gear was 600 and this everything is 600 and this one continued to be 482, if this side was 482.77, would the calculation be different? If everything is 600 volt, but this transformer is taking 600 to 482.77, would the calculation be different? No. Up to 600 volt, guys, up to 600 volt, what you did is basically the same. Doesn't matter what the voltage is. Does not matter what the way we calculate doesn't matter. Because the answers will be different, because based on the voltage we find a few things. But up to 600 volt, this calculation is valid. DC is slightly different. High voltage is slightly different. Not that by much, by the way. Any question about bonding and grounding? So this is basically all what you need about bonding and grounding in one sheet. Go eat. Almost. Mr. Beb? The transformer, you don't need it.